All right, so let's look at all the even ones. So my a is equal to 2, so a is bigger than 0, so then my leading coefficient is positive. My function is concave up because it's positive. So that means that as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches infinity. Okay, my x-intercepts would be to set this equal to 0. I don't think this factors. It's going to make me sad, I think. So negative 6 on the bottom, 4 on the top. Yeah, that's a big no. Okay, so quadratic formula, x is equal to negative 4 plus or minus the square root. 4 squared minus 4 times a times c all over 2a. So x is equal to negative 4 plus or minus the square root of 16 plus 36 all over 4. So x is equal to negative 4 plus or minus the square root of 52 over 4. So 2 and 26, 2 and 13. So then x is equal to negative 4 plus or minus root 4 times root 13 all over 4. So x is equal to negative 4 plus or minus 2 root 13 over 4. So then x is equal to negative 4 over 4 plus or minus 2 over 4 root 13. So x is negative 1 plus or minus 1/2 root 13. So in theory, when I do this, it would be negative 1 plus 1/2 root 13 comma 0, and then negative 1 minus 1/2 root 13 comma 0. So that would be my x-intercepts. Concave up, positive infinity, and positive. I keep forgetting to fill in the little buckets, the little boxes things. Okay, so my y-intercept, y is equal to 2 times 0 squared plus 4 times 0 minus 3. So y is equal to negative 3. So my y-intercept is 0 comma negative 3. And then my symmetric point, we will find in a second. My vertex is x is equal to negative 4 over 2 times 2. So negative 4 over 4, which is, just kidding, negative 1. So if I have negative 1, y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 3. So 2 minus 4 minus 3. So then negative 5. So my vertex is negative 1, negative 5. And then it is opening, I don't remember anymore, opening upward. So this is, just kidding, I already did concave, minimum. And this is all values of x. Let's see, negative 1, 2, 3, 4. Oh my goodness. 1, 2, 3, 4. Okay, and then my y-intercept is at 3. So that makes my symmetric point at negative 2 comma negative 3. Oh my goodness, I cannot write. Negative 2. Okay. And then my range, my domain then my range is that y has to be bigger than or equal to -5. All right. Okay, so for my leading coefficient, a is greater than 0, so this is positive. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches infinity. Concave upward. Okay, so my x-intercepts, oh, just kidding, yeah, 0 is equal to 5x squared minus 3. Add 3 to both sides. Divide both sides by 5. So x is equal to plus or minus the square root of 3/5. Oops. So that means square root of 3/5, comma 0, and then negative root 3 over 5, comma 0. My y-intercept is, just kidding, 5 times 0 squared minus 3, which is -3. So my y-intercept is 0, comma -3. And then my symmetric point, I'll find afterwards. My vertex is x is equal to -0 over 2 times a. So then I get 0. So if x is equal to 0, then my y is equal to 5 times 0 squared minus 3, which is -3. So my vertex is 0, comma -3. Which makes it hard because, okay, so 0, comma -3. Because your y-intercept, what makes it hard is that the y-intercept is also the vertex. So you're going to have to do something different. Okay, so this opens concave upward, so this is a minimum. And I cannot spell minimum. And then my domain is all real numbers. Oh my goodness, I cannot write. And then my range is going to be higher than my y value for the vertex. So y has to be greater than or equal to -3. Okay, so now seven is minimum. Okay, so now my vertex is 0, comma -3, which is also the same thing as my y-intercept. So then I will pick a point to the left or to the right. When I plug in 1, I get 2. Yes. And x is equal to 1. Y is equal to 5 times 1 squared minus 3, so I get 2. Okay, so then my symmetric point is on the other side. And it looks something like this. So -1, +2. Okay. All right, and that is it for this lesson.